Water leaking from inside a dam. At first, that looks like a serious problem. After all, isn't a dam supposed to keep water out? But this is not a leak, it is actually one of the most important safety features. Welcome to the drainage gallery, a hidden tunnel built deep inside the dam, where engineers don't try to stop every drop of water. They collect it, monitor it, and safely drain it away. We will come back to this fascinating system in a moment. But first, let's continue following the journey of the water itself. In the previous section, we saw how the sediment basin slows the water down, allowing sand and silt to settle at the bottom. That leaves us with another important question. Once all the sediment settles, how do engineers remove it before these giant basins fill up? Let's find out. At first glance, the answer seemed to be this: the jetting system. A network of pipes runs along the walls of all three sediment basins. Water is taken directly from the reservoir and fed into these pipes. At several connection points, workers can attach flexible hoses. High pressure water is then used to break up the compacted sand and silt on the basin floor, making it easier to flush away. It looks like the perfect cleaning system, but here is the surprising part. Most of the time, they don't even need to use it, because these sediment basins were designed to clean themselves. Here is how it works. Each basin can be taken out of service independently, while the other two continue supplying water to the powerhouse. First, the intake gate and the outlet gate of one basin are closed, isolating it from the rest of the system. Next, the flushing gate at the downstream end is opened. The remaining water inside the basin drains rapidly through the flushing gallery, returning to the river. In about 10 minutes, the entire basin is empty. Now comes the clever part. The flushing gate stays fully open, but instead of opening the intake gates completely, engineers raise it by only about 500 millimeters. That's a small opening. That small opening creates a powerful high-speed jet of water. As it races across the empty basin, it sweeps the remaining sand and silt along the floor, carrying everything straight out through the flushing gate. No workers inside, no excavators, no manual cleaning. Just carefully controlled water doing all the work. Once the basin is clean, the flushing gate is closed. The basin is refilled, the intake gate is fully opened, and finally the outlet gate is reopened. The same process is then repeated for the other two basins, one at a time, so the powerhouse keeps receiving water without interruption. The jetting system is still there as a backup whenever extra cleaning is needed. But thanks to this clever flushing sequence, most of the sediment is removed automatically. It is a simple idea, yet an incredible elegant piece of hydraulic engineering. Now these gates are called outlet gates. Installed above the flushing gallery are 12 outlet gates, 4 for each sediment basin. Their job is completely different from the flushing gates below. While the flushing gate removes the heavy sediment, the outlet gate collects only the cleaner water near the surface, allowing it to continue its journey towards the powerhouse. As the outlet gate opens, the flow enters this concrete channel known as the collecting canal. Think of it as a joint meeting point where water from all three sediment basins combines into a single stream. From here, the water enters the Hydroelectric tunnel and begins an incredible journey of nearly 39 kilometers through the mountain before finally reaching the powerhouse. By now, most of the abrasive sand and gravels have already been removed, protecting both the tunnel and the turbine waiting for downstream. Now we are heading somewhere almost no visitors ever get to see. Hidden beneath the intake inside the dam is the undersluice gallery. This is where the hydraulic system that operates the undersluice gate is installed. The moment you step inside, everything changes. Outside, you hear the spillway. Inside, the air is cool. The tunnel is dimly lit. and one sound takes over: the deep roar of rushing water. That roar tells us something. One of the undersluice gate is open. Just beyond this concrete wall, thousands of liters of water are rushing beneath the intake every second. But why? As the reservoir carries sand, gravel and silt downstream, some of it settled right in front of the intake gate. If left there, it would gradually block the flow of water entering the sediment basin. That is where the undersluice gates comes in. Installed just below the intake gate, they release a powerful flow that sweeps the accumulated sediment back into the river downstream, keeping the intake clear. Operating gates this massive takes enormous force. That is why this gallery houses powerful hydraulic units. They pump high pressure oil through steel pipes to large hydraulic cylinders, which raise and lower the heavy steel gates smoothly and precisely. Every movement is monitored, every operation is controlled from the control room, because when you are handling this much power, there is no room for error. Standing here with the sound of water echoing through the tunnel, it is easy to forget that most visitors will never see this hidden world. Yet beneath their feet, this underground hydraulic system works around the clock, quietly protecting the intake and keeping the entire hydropower project running safely. So far, we have followed the journey of the water from the reservoir through the intake into the sediment basin and through the underground tunnel. But now we are leaving the water behind. We are heading to a place built for one purpose: to protect the dam itself. This is the drainage gallery, one of the most important yet least noticed part of the entire dam. This is the lowest level inside the dam. The tunnel is narrow, it is quiet. You can hear water dripping from the walls. There is no joint gates, no huge machines. Yet this simple passage plays a critical role in keeping the dam safe. During construction, it was built deep inside the dam, close to its foundation. Today, it works around the clock. Most people think concrete is completely waterproof. It is not. A tiny amount of water always finds its way through the concrete and rock below. That doesn't sound like much, but if the water gets trapped beneath the dam, it starts pushing upward. This is called uplift pressure. Over time, that pressure can place extra stress on the foundation. So instead of trying to stop every drop, engineers gave the water a safe escape route. Hidden beneath this gallery are deep drainage holes. They collect the seepage water and guide it safely into this chamber, where it is carried away before pressure can build up. In simple words, this gallery lets the dam breathe. It's quite system, but one that helps keep millions of tons of concrete stable. This gallery is also an inspection tunnel. Engineers regularly walk through, checking how much water is coming in and making sure everything is performing as expected. Dams aren't built and forgotten. They are inspected throughout their entire life. Finding a small change early is always better than fixing a big problem later. Walking through these tunnels after almost 10 years bring back many memories. During construction, this place was full of workers, equipment and activity. Today it is quiet. Everything is operating exactly as it was designed. As an engineer, there is nothing more satisfying than returning years later and seeing a project doing its job perfectly. Most visitors only see a giant concrete wall, but inside there is an entire hidden world. Steel gates, hydraulic systems, underground tunnels, drainage system, monitoring equipment, all working together every day to keep the dam safe and reliable. That's what makes them so fascinating. That's not just walls holding back water. They are carefully engineered systems designed to control one of the nature's most powerful forces.